Mhm.
All right, well, it's my great pleasure to introduce our speaker today, Dr. Jonathan Foley. John's a world-renowned climate environmental scientist whose research has had major impacts on our understanding of global ecosystems, food security and the environment, climate change, and the sustainability of the world's resources. Now, he's published over 130 articles, including highly cited works in Science and Nature. Indeed, his 2011 Nature paper on solutions for a cultivated planet is one that certainly influenced some of my own research. Now, John's received numerous awards and honours, a sample of which include a Presidential Early Career Award, the McDonnell Foundation Science Award, an Aldo Leopold Fellowship, and in 2014, he was named the winner of the prestigious Heinz Award for the environment. Now, he's also been recognised as a highly cited researcher for a number of years now, placing him in the top 1% of most cited researchers in the world. Now, it's our good fortune that apart from his scientific credentials, he's also a noted science communicator. John's a prolific writer with many popular articles, op-eds, and essays in publications like National Geographic, New York Times, The Guardian, Scientific American. He's had presentations featured in hundreds of international venues, including the Aspen Institute, the World Bank, National Geographic, TED, and now, of course, our very own KAUST ENSE seminar series. Now, currently, John serves as the Executive Director of Project Drawdown, the world's leading resource for climate solutions. And when we talk about research to impact, this is a living, breathing example of that. I've been following the work of Project Drawdown for some time now, and I'm very excited to hear more about this and anything else that John might diverge into today. So with that, John, the virtual floor is yours.
Great. Well, thank you so much, Matthew. And let me share my screen so I can give a little presentation from here. It's wonderful to be with you today. Thank you all so much for the opportunity. Let me just turn this on. It should be displaying now. Is that looking okay? Okay, good. So today, we're going to be talking a bit about the some work that we're doing on solutions to climate change, one of the kind of big environmental issues of our time. Certainly not the only one, though. There are many other issues related to land use and to biodiversity loss and other things happening at the global scale. But I think climate change is one that's kind of endemic of all of them, but also quite interconnected to everything else that we're doing. But as we begin to think about the solutions to problems like this, I sometimes think it's useful to start from the beginning and wonder, how did we get into this problem in the first place? What's quite extraordinary about our time in history is that we live in an incredibly unique time in all of human existence. In just the last 50 years, for example, we've seen an explosion of human footprint across the planet, whether it's through the total population of the Earth, which has increased dramatically in the last few decades, or the fact we've now shifted very suddenly to being an urban species for the first time, or the incredible explosion of human economic activity in the last few decades. We've seen something quite extraordinary, something we often call the Great Acceleration. For example, in the last 50 years, human population more than doubled. The economy grew between 5 and 6-fold, even adjusting for inflation and purchasing power, resulting in a global food demand increase of about 3-fold, water use about doubled, and fossil fuel combustion roughly tripled in just 50 years. Which means that the last 50 years have changed more than not only any time in history, it's changed more than history itself. And perhaps for the first time, we can really unequivocally say that our footprint is not only disturbing the local environment, which humans have always done, but now we're disturbing large-scale planetary systems as well. And that comes with a different level of risk and different level of impact than we've ever seen. And it's something we need to reconcile ourselves with. Now, some of these changes are, of course, quite visible, whether it's the changes to our ecosystems. For example, here a picture of the Amazon rainforest from the 1970s compared to one just from the early 2000s. Most of that forest was lost to grow soybeans, interestingly, most of which were shipped to China as animal feed, but that and other activities around the world, mainly for food, but also for timber and minerals, have lost roughly 30% of the world's tropical forest covers have been lost, most of which in the last century, a lot of which in the last few decades. We've also seen tremendous disruptions to global water resources, including things as large as the Aral Sea, huge inland sea of Central Asia, of course, here shown in the early 1970s, but here in the early 2000s. And that difference was not due to climate change, but because the then Soviet Union diverted the water that fed the Aral Sea and used it to irrigate the Kazakh deserts to grow cotton, and thus collapsed one of the world's largest inland water features. And so these changes to ecosystems, changes to the water landscapes of our world, if you will, have been very obvious. They're visible, we can see them, we can show you photographs of them, and there's no question about that. And this collapse of land and water is well documented and really happening just due to our activities. But then when we get to the issue of climate change, it suddenly becomes a little more difficult to talk about because by its very definition, we're talking about an invisible gases building up in the atmosphere, CO2, methane, and other gases. And our eyes can't see them just because of their physics. They're transparent to solar and visible radiation, but more opaque in the infrared radiation wavelengths, thus trapping heat near the Earth's surface, changing the Earth's climate, this kind of a notion of the greenhouse effect. Now, this isn't new. Certainly, you've all heard about it before. But in fact, this idea is so not new. We actually knew about it as early as the 19th century. Some of the earliest writing about the idea of a greenhouse effect actually goes back to the 1830s, even before this graph. But the very first real discovery that CO2 increases could be linked to temperature increases actually was made by, surprisingly, I didn't know this until a few years ago, an American woman named Eunice Foote was actually the first person on Earth to publish a paper in 1856, I believe, showing that, in fact, increasing CO2 could lead to increased warming around the planet. Usually the credit for this is given to Joseph Tyndall, but he actually published his work 4 years later. So we need to correct our history books and recognize an extraordinary woman who first made that connection. But with this increase in CO2, which happened over the last 150 years or so, we've seen a very, very sensible, very predicted, very physics consistent increase in the world's temperatures. And the global mean temperature has increased by about 1 degree Celsius so far. And obviously those curves are both going up in terms of greenhouse gas concentrations and the warming of our planet. None of this is new to you. You've all heard this before, but I just want to set the stage and talk about this kind of incredible challenge we have of a now sudden explosion of the human footprint and consequent changes in all kind of planetary indicators around the environment. This could, of course, look like an incredible challenge, and it is. There's no question of that. But here I want to depart from a lot of the talks you usually hear about climate change and tell you right now, things are not hopeless. There are, in fact, solutions to all of these problems. We just have to choose to use them. And that's the problem. We have to make a choice about what kind of future we want to build. Because the future isn't written yet at all. We could choose a world that avoids more catastrophic levels of climate change or one that doesn't. And that's a choice that'll define our future history. And climate change will be very important to be addressed, I believe, because it's so central to a lot of the things we care about in building a better future, whether it's our own security, our economy, our natural resources, our health, and so on, are all linked to climate change, whether or not we like it. And so climate change is kind of a pillar upon which we'll be building our future society, and we need to address it square on. That's what our organization does. I run this thing called Project Drawdown, which is a small nonprofit that's basically filled with half scientists and analysts and about half communicators and writers. And our job is to kind of analyze, review, and research the world's possible climate solutions from an unbiased, non-partisan, non-commercial perspective, just based on science, and then share them not only with the academic community, but more importantly with the broader world. We use the word drawdown quite specifically to mean something. Drawdown in our parlance does not mean carbon removal. That's not what it means. It actually means a point in time. What basically we're talking about here is right now, this is the history of the increasing levels of greenhouse gases, CO2, methane, and others, increasing in the atmosphere. And the question, of course, is what happens next? Will those levels continue to increase as we emit more and more into the atmosphere, kind of filling up the atmosphere more and more of these greenhouse gases? Or do we bend the curve, as we've been saying a lot lately, or in epidemiology, but it also applies to our planet. Do we change the course of history by bending the curve of greenhouse gas levels downward? And if we do, we hit a point here, this inflection point, that is the moment of drawdown. Drawdown refers to that moment in time when greenhouse gases stop building up in the atmosphere, they level off, and they maybe even begin to slowly, steadily decline, thereby halting future climate change. And the mission of our organization is to try to help the world get there as quickly, safely, and equitably as possible. So, how do we achieve drawdown? Well, to do that, we have to first understand the problem. As I mentioned already, of course, the greenhouse effect is caused by multiple gases, and we humans have historically increased three big ones, and a few others, of course, but these are the ones we have long term data on. They include CO2, methane, and nitrous oxide, and a fourth category of gases I'll tell you about in a minute. But as you think about climate change, when you ask most people in the world what causes climate change, they will usually say it's due to CO2 released from the combustion of fossil fuels. That would be 62% correct if you measured it in terms of the actual warming, the kind of watts per square meter warming this planet due to our activities. So it's by far the largest part of the human greenhouse effect, but it's not the only part. And I think it's important to recognize there are some other contributors as well. But clearly, fossil fuels are the lion's share of this problem, and we need to address that accordingly. Another source of CO2 is from kind of industrial chemistry, making and different chemicals and processes that we use on this planet that release CO2, including the manufacture and use of cement. In fact, if cement were its own country, it'd be something like the probably fourth largest emitter of greenhouse gases on the planet. Another big emitter of CO2, of course, is deforestation, especially when trees are burned. Burning a tree isn't that different than burning a coal. They're both made out of carbon. One's just alive and one is dead. But when you burn carbon, it doesn't really matter. Both form carbon dioxide and are released to the atmosphere. Then we have methane. Methane is kind of a combination of sources at work here. First, from industry, especially mining natural gas through fracking, where there are often leaks into the atmosphere from those infrastructure facilities and so on. Also, kind of fugitive emissions, flaring, and so on. But also natural gas pipelines, all the way to our appliances inside buildings. They all leak methane somewhat. Even small amounts matter a great deal because this gas has an incredible potential to cause global warming. Methane is also released from agriculture, though, primarily from ruminant animals, from cattle, especially sheep and lambs, things like that also release methane. And so this gas is kind of a mixture of agriculture and the energy industry. We also have nitrous oxide emitted from primarily agriculture, a little bit in the industrial sector. And nitrous oxide primarily comes from farm fields that are over fertilized with chemical fertilizer or manure. And the nitrogen in the manure and fertilizer combines with water and air at some conditions and releases nitrous oxide into the atmosphere. And then finally, this last gas, which only contributes about 2% of the recent warming, called fluorinated gases, is a family of actually hundreds of different chemicals, mostly used in industry, primarily for a refrigerant. It's used in air conditioning and refrigerating units, freezers, things like that. That number is poised to grow dramatically as much of the world joins the middle class. In fact, about 2 billion people in the world are poised to probably buy their first air conditioners in the next decade or so. And most of the people live in pretty warm places and with little or no regulation about the fate of those gases as you dispose of a refrigeration unit or air conditioner. So that 2% could actually become a much larger number if we don't watch it. So that's kind of the chemistry side of this, of where the gases are heating up the atmosphere and why we have to pay attention to different gases in different sectors. But I actually find this perspective to be even more helpful. This is kind of looking at the human agency of what's happening in the atmosphere due to us and what we can do about it. If you imagine the atmosphere as a stock and flow problem, kind of like a bathtub that you can fill up with a faucet, but you can also empty with a drain, and the level of water is the balance between those sources and sinks of water. We can think of the greenhouse gases in the atmosphere similarly. There are things that add greenhouse gases to the atmosphere, the sources of greenhouse gases. These are the human sources. This is above and beyond natural sources and sinks. These are things that we humans have added on top of what the atmosphere currently and historically has had. And you can see that we broke down the emissions into different kinds of sectors, which we'll dive into later. But you see things like electricity, industry, transportation, food, buildings, and so on. So those are the things filling up the atmosphere with more and more greenhouse gas over time. Interestingly, though, that's not the only thing happening to the atmosphere. The atmosphere also has a way of naturally removing some of those gases, though not all, into what we call carbon sinks, primarily on land in healthy forests, for example, but also in the oceans, primarily through chemistry and biology. So that's kind of the current balance. Let's say 100 units go in, about 41 in this picture are removed by nature, leaving behind each year about 60% or 59% of greenhouse gas emissions into the atmosphere. Now that's total greenhouse gases, CO2, methane, and others. If you're only looking at CO2, it'd be about 55%, and 45% remains. But when we adjust for the other gases, these numbers change somewhat. So this is the current picture of why greenhouse gases are building up. We're adding more to the atmosphere than nature can absorb. The balance is left over, accumulating year upon year, adding to greenhouse gas levels and thus heating the atmosphere more and more. But to achieve drawdown, this moment when we stop climate change, we have to do something about this. And I think it's useful to visualize this in the same picture. Today, again, we have a buildup of greenhouse gases. They're increasing because we're putting more in than nature can remove. Very simple. If we want to stop the greenhouse gas accumulation and stop the additional warming of our atmosphere, we have to do two things, one on the left, one on the right. First is we eventually have to bring these sources that we humans emit down towards zero, or at least to net zero. The idea here is that we would slowly phase down these emissions, which is happening in about 45% of the 45 countries in the world are now lowering greenhouse gas emissions. And this year, due to the pandemic, undoubtedly the world will as a whole, at least temporarily. But we need to bring these not only down a little bit, we need to bring them to zero. And we have to do it fairly soon. But at the same time, it would be very helpful to help nature maintain some level of carbon sinks. These sinks are sometimes proportional to the emissions on the other side, so they probably will go down no matter what. But they'll also go down if we start to harm the world's forests or if the world's oceans become more compromised over time, which is starting to happen. So, but if we can help nature and simultaneously bring our emissions to zero, then that's when we bend the curve, greenhouse gases start to decline, we hit the moment of drawdown, and we can stop climate change. So our organization actually looks at taking that kind of starting point of a systems view. We start to look at the climate solutions that may be out there and starting from those basic principles, first of which is to reduce emissions to zero. So let's start there and talk about that for a while. We'll get to the nature and carbon sinks part a little bit later. But first, what can we do to reduce the primary pollution? Well, again, it's very helpful to know where they come from if you want to stop them. Here are emissions sectors that we know about. These are data for the 2010 decade, roughly. They change a little bit from year to year, but this is roughly correct for the last decade. But this is at the global level. If I were to show you numbers for Saudi Arabia or for the United States or China or the Netherlands, you'd get a somewhat different picture. But this is the global total, so which ultimately is what's important. Electricity production, burning coal and natural gas primarily, is about 25% responsible for recent climate change. The food, agriculture, and land use sectors, which are often ignored when we're thinking about climate change, but they're roughly equal to electricity production as a contributor to climate change. And it's the second biggest source. And it's interesting that food and electricity are about half the climate problem. All industrial emissions are about 20% here, which is quite interesting. The transportation sector is about 14%. Buildings directly emit carbon through furnaces, boilers, hot water heaters, and so on, but also refrigeration units that are leaking on their site. Buildings, of course, use electricity and they consume food inside because that's where we eat usually, and there are industries and so on. But here we're looking at the direct footprint of buildings. Buildings, of course, have a secondary impact of being the place where a lot of these other emissions transpire, but buildings aren't responsible for them directly. And then everything else being 10%, a lot of that is in the energy industry itself. But I think it's quite interesting to note that about 90% of global climate change is caused by 5 things: electricity, food, industry, transport, and buildings. And that's kind of an easy set to remember. So if we go through those, electricity, for example, being that first 25% of climate change right here, we can actually look at how it's being produced, of course. Let me go back. Whether we use coal or natural gas to produce electricity versus, let's say, solar panels or windmills, that kind of thing, that would change dramatically the emissions associated with electricity production. So changing the way we make electricity is obviously part of that problem. But the other side of the problem, of course, is energy use itself. Even if we continue to use coal and natural gas in some parts of the world, can we be more efficient about it? And so we also look at the demand side of the equation, not just the supply side, and break down where electricity is used. Interestingly, most electricity in the world is used in buildings, and then in industrial processes, and then 2% for everything else. So when we look at solutions, we've reviewed hundreds of different kinds of solutions. We will start with things like efficiency. And electricity, energy efficiency includes all of these solutions I bolded down below, each of which we've analyzed independently. But I want to show you the kind of family of solutions around like building automation, better lighting, better glass, better roofs, better heating systems, better building components, and so on. So those are ways we can dramatically increase efficiency, a lot of that in buildings, some of that in industrial processes as well. We can then also shift the way we produce electricity to the usual suspects of solar, wind, hydro, geothermal, biomass, maybe nuclear, some waste energy, methane capture, and so on. But what I want to show you really is the summary of all this. It's sometimes very exciting to talk about one climate solution as if it can do the whole job by itself, but that's simply not true. I think you'll see again and again and again, we need many solutions to climate change to get to the kind of numbers we need. And when just in electricity, for example, all of these circles represent different solutions to climate change. And the size of the circle is our estimate of how much impact they'd have on the atmosphere in the coming decades in our kind of scenarios. And some solutions, we even have 2 circles representing a range of possibilities that we think are plausible over the next 3 decades. And so we see here a mixture of energy efficiency, but especially shifting energy production to low carbon sources. And those being very, very important to this sector. But again, that's 25%. There's 75% to go. And we can look at the food system also as a major emitter of greenhouse gases. And that 24% is mainly broken down into 3 big areas and some other things. But first and foremost would be deforestation, clearing new land in the tropics mostly for agricultural production. Whether that's palm oil or whether that's going to be for cattle or for soybeans and animal feeds, things like this. Animal agriculture is a big part of this, but so are other things. The second biggest emitter would be methane, largely from ruminant animals, especially beef, but also lamb and other things. But also a little bit from rice fields. Rice can also emit methane under certain circumstances. And then the third biggest area would be nitrous oxide by using too much fertilizers. Everything else is the remaining 5%. And that includes dozens of different things. So I think it's actually probably best to remember the 3 big ones: deforestation, meat, and a little bit of rice, and fertilizers are kind of the biggest levers we have in the food system. And just like in electricity, we can be more efficient with the system we have by reducing food waste and perhaps eating more plant-based proteins instead of animal proteins would help a lot too, especially reducing consumption of beef and dairy products somewhat. Then we can also protect ecosystems from being cleared, especially those that are subject to deforestation. Here are a number of solutions around different ecosystems, around forests, but also grasslands, peatlands, and coastal areas. And then we can farm better, of course, too, on the lands we have, thus reducing the emissions directly on those agricultural landscapes. And those solutions would summarize look something like this. It turns out reducing food waste and changing our diets are by far the largest impacts we can have. Protecting ecosystems like forest is really important. Also, forests that happen to have peatlands on them, especially in places like Indonesia, is really crucial. And then in the upper right-hand corner is farming better, especially managing nutrients and rice and other things a little differently. We'll see later that there are other things we can do on land that absorb carbon, creating a carbon sink. But this here is only looking at the reduction of carbon sources, that is what land emits. We want to cut down to zero. Industry, I'll go more quickly through the rest of these. It's about 21% of remaining emissions. These are actually much more complicated because it's actually broken into numerous economic sectors, including making steel, making cement and concrete, a lot of chemicals. Of course, the kind of plastic and polymer industries are in here somewhere too. Waste management globally is also a couple percent, very, very important. We've not looked at all possible industrial solutions. We're beginning to add a suite of others that we haven't yet quantified. But we find refrigerants are really important because disproportionately they heat the atmosphere more than about any other chemical per mole. We also have changes in cement, in plastics, and also managing waste better to either recycle things, compost them, or capture energy from our waste streams. Transportation is going to be very important to the solutions of climate change as well. But again, total 14% of emissions, most of that on the roads of the world. Flying is also very important because actually it's a relatively small number of people do a large share of the flying. So we have to be a bit careful about that. But right now flying is about 1.8% of global emissions for the last decade, but still very important. And again, the solutions tend to be a mixture of efficiency, shifting to alternatives, and maybe electrification down the road. These are all really crucial as well. And then finally, we'll take a look at buildings, which are directly not accounting their electricity consumption or the fact that transport goes to buildings, but just within the building themselves. And about 4% of that 6 come from residential buildings, which is 2 to 1, the emissions coming from commercial and public buildings. So that's pretty interesting. It's mostly homes that we have to be thinking about. And again, we can look at efficiency improvements and also shifting to alternative ways of doing things. You'll notice clean cook stoves are really important here, especially because in much of the developing world, burning very dirty fuels for cooking and heating can lead to tremendous emissions of also black carbon, which is another heating element of the atmosphere. But you'll see quite a few other familiar things here as well. So I just went through a long list of ways we can reduce emissions, but they all have a similar pattern of enhancing efficiency and transforming to a better system. We can also, though, look at the sinks of greenhouse gases, primarily sinks of carbon dioxide, that come from, right now, all from nature. Humans are not creating carbon sinks at any meaningful scale yet. We could, perhaps, but right now we're talking about nature. And so a lot of our solutions are about protecting and enhancing the natural carbon cycle that's absorbing about 40% of greenhouse gases today. Again, we can talk about technologies a little bit later. But for today, most of the sinks of carbon are based on land because land is doing photosynthesis and building up biomass, primarily as forest, a little bit of grasses as well. And also building up soil carbon, soil organic matter, which stores carbon for quite a long time in the soils. So these are different solutions we can use to maintain and protect the current carbon sinks that we see, but also maybe add to them by using our working landscapes. So in the middle, we're restoring and protecting kind of the natural systems. To the right, we're restoring kind of degraded lands of the world. But on the left is using our croplands and pasture lands, which are enormous areas of the planet, and managing them in the ways that may accumulate more carbon in the soil. Largely, this class of practices is called by a few people regenerative agriculture, the idea that agriculture can be kind of restorative and regenerative to the landscape, not just kind of wearing it down, but building it back up again. That's very, very interesting, and there's a lot of debate about how big those sinks could be. Our numbers are fairly conservative and show that they could be important, but they're not the whole solution. Then we can get to the oceans. Oceans, of course, absorb CO2 for 3 different reasons. One is just simple solubility. CO2 chemically dissolving in seawater. The bad news is warmer water holds less CO2 than cold water, so you might expect that to go down in the future. The second way oceans absorb CO2 is through what's called a carbonate pump, and that short version of that is basically building of things like coral reefs and shellfish and anything that makes calcium carbonate as skeletons or as shells around living things. And then finally is the just kind of normal photosynthetic biological pump of phytoplankton and kelp, basically drawing CO2 out of the atmosphere and that organic matter settling down to the bottom of the ocean for a long time. So those things we could affect in the long run. Right now, the oceans though are pretty much doing whatever they're doing without much human intervention, at least not a positive human intervention. Although I think things like protecting wetlands and mangroves could be a very important first step of enhancing and maintaining these sinks. Lastly, people get very excited about the idea that humans could build machines that remove CO2 from the atmosphere, and we have. But they're very, very expensive. They're very, very small scale, and have had absolutely no effect on the atmosphere yet so far. Maybe in the future decades, certainly not years, these could be very, very important. But we have a long, long way to go to make them commercially viable and built at the scale that they would matter. So I would put those out as more speculative compared to what we can do today with things like forest and oceans. But nevertheless, could be very important maybe in the coming decades. So we should lose sight of that. So we've looked a lot at how we can reduce the sources of greenhouse gases, how we can help nature maintain the sinks of greenhouse gases. What I didn't mention was a third opportunity for climate solutions that come from things that really are not technically a climate solution, but they're often a solution to other problems that can actually affect climate change in a positive way as well. And maybe largely in the category of improving society. In particular, the question about the educational and healthcare access and opportunity for women and girls. In many countries of the world, as girls and women get more educational opportunity and more access to primary healthcare, closing the gender gap between men and women in much of the world that we're beginning to see in many places, is often a great idea. It unleashes creative and economic opportunity for women and the society as a whole. But it also changes reproductive behavior. As women get more education and more access to healthcare, they'll have much healthier children, but also fewer children and children later in life, which begins to bend the curve in population growth. Now, population growth is not the primary cause of climate change at all. Primarily, it's the small group of fairly rich people in the world who emit most of the greenhouse gases. But down the road, in the coming decades, population growth could be important too, because other people becoming more numerous and wealthier in the future is combined to increase future emissions. So it's something that matters, though it's not the primary driver. But when we put it all together, we find that we can see that many solutions to climate change exist. In our earlier work, we used to look at ranking them, where we'd make a list from 1 to 100, let's say, and show you which greenhouse gases solutions might be the most important. I don't really find this very useful because the rankings are fine and everything, but we have to do all of them. So who cares what's number 8 versus number 12? We have to do them both anyway. So I'd actually prefer to show you them like this, where we look at families of solutions working together. For example, the solutions that begin to reduce sources of greenhouse gases from the beginning, and knowing we have to do this in electricity, we have to do it in food, we've got to do it in industry, transportation, and buildings, and we have to do all of that at the same time. The circles show kind of big families of solutions within which there might be a dozen individual ideas, but these are kind of the big areas. And none of them are, orders of magnitude larger than the others. There's no one solution here. We have a whole bunch of them. Then we have ways that can enhance and support the sinks of carbon, primarily in nature, and for now, primarily on land, or where we know we can do things. As more ideas about helping the oceans maintain their carbon sinks and maybe enhancing them, that blue area can grow. And as the engineering prowess of the world increases, maybe that kind of engineered sinks could increase as well too. But right now, carbon sinks is primarily a game on land. And then if we include this kind of secondary effects that feed back into climate change, but not really done on behalf of climate change, especially improving access to health and education for women and girls, we see improvements in society as a whole also feed back into climate change and can be part of that solution too. So all of these solutions are needed to do the job. And if we throw all of those solutions up into the world at the same time, that is perhaps the only way we can stop climate change. We cannot do it alone in electricity or industry or with carbon sinks. Absolutely no way. But when we use all of the solutions available to us today, there's still a chance that we can stop climate change before it gets very destructive and reach that point of drawdown. So we take these solutions that we've modeled before of how large they might be and how expensive they are and so on, and then run them through an atmospheric chemistry and physics model and find we can look at different scenarios of the future. The red curve is kind of a baseline. This is the IEA kind of estimate of future emissions and concentrations that would result of CO2 equivalent here. This is putting all the greenhouse gases into a common currency. And the baseline is, if you will, if we just continue on the current path. But then we created two scenarios, one that's very aggressive and stops climate change sometime in the 2060s, and one that's very, very ambitious and that could possibly stop climate change into the 2040s. The second scenario is kind of the most optimistic scenario we could imagine. And when we do that, we find that the world stabilizes temperatures at either 2 degrees in one scenario, which was the original Paris target, or the modified Paris target that politicians introduced later in the meeting of 1.5 degrees, which is extremely ambitious and a lot of people think is perhaps impossible. We've demonstrated that it's at least physically and economically possible, but politically and socially, it'd be a very challenging belief to make that happen. But at least it's possible. So these are ranges of possibilities. Of course, anything between those curves is possible too, but this is just meant to illustrate the point. The bottom line here and the lessons we could learn is that we do have enough solutions to stop climate change today, but we also have to look at the cost of doing so. Initially, climate solutions do cost money. Here's what was called a kind of a cost curve, where we look on the x-axis, the horizontal axis, the total sum of the solutions in terms of gigatons of carbon dioxide avoided. But on the vertical axis is the net cost initially. Most of the solutions have a fairly large net cost, some towards $500 per ton, some much higher than that. A few actually have immediate savings the minute you turn them on because they're just cheaper than the current fossil fueled alternative already. But the real interesting point is when you look at the lifetime operational cost and replacement cost of a fossil fuel world versus this new drawdown world, we find actually the world saves enormous amounts of money for most climate solutions. In fact, total, we find that we'd have to spend about $25 trillion to make the pivot to drawdown, but we'd save between $90 and $140 trillion by the end of 30 years, not counting the damages climate change would have caused if we hadn't stopped climate change at a smaller level. So this is an incredibly good economic opportunity globally. Of course, some sectors will lose, some others will win, but overall the global economy could create hundreds of millions of new jobs and create enormous sums of new wealth and avoid catastrophic damage. So to us, this seems like a fairly good idea. There are a lot of lessons here, of course, and I'll wrap up here to shift to some questions. But first and foremost, it is not too late to stop climate change. We can reach that moment of drawdown if we start scaling solutions we have today. It's very tempting, though, sometimes to wait for a new technology that might be better to solve our problems. We urge caution in that thinking. We've already wasted 30 years, 40 years really, in not acting at a sufficient level. And if we'd started to act seriously in the 1980s or so, 1990s, it would be a much easier job today. But now we've waited far too long, and basically we have to start now, no matter what. And so in our business, it's not that we need more tech, we need more time. And we often will say in our organization that now is better than new. We have to deploy what we have now and maybe replace it with better technologies later, but you cannot wait any longer. And to do this, we need to use kind of the accelerators that put solutions into the world, whether it's the changes in the rules, policies, law, regulation, way taxes and incentives are used by governments of the world, for example. We have to shift trillions of dollars of capital, most of that out of things like the fossil fuel industry and industrial agriculture, which will be very upsetting to some. But also creating new capital opportunities in renewables and different kinds of agriculture and so on. But we have to move trillions of dollars and do it soon. Changing business practices, changes in targeted technologies, changes in behavior are also going to be very important too. But changing policy and changing capital are probably the two big levers here. And if we think about how they get deployed in the coming decades, this will be a long game. We can't do this in 1 year. This will probably take 20, 30, 40 years to really go on this journey, but we have to start today. And one of the areas to start is to deploy the already cost-effective solutions, things like energy efficiency, reducing food waste, stopping deforestation. Those are all things we can do right now. And we can also deploy renewables. This is a cost structure for electricity in the United States, but it applies to many other parts of the world too. And finally, solar and wind are so cheap, they are actually quite competitive with coal and different forms of gas, and quite a bit cheaper than nuclear is in the Western Hemisphere. And so that's the obvious solution. And that's why we're seeing exponential kind of Moore's law increases in solar and wind today. Even though they're still small, they're growing exponentially very, very fast. A second wave of solutions, though, also needs to begin today and will take decades to finish, but it's changing all the infrastructure behind some of our emissions, especially in industry, but also transportation. Every internal combustion engine on the planet will have to be retired soon. Every furnace, every boiler, every hot water heater, all need to be removed and replaced with things like heat pumps. That will take decades because we're talking about billions of buildings and vehicles in the world. That'll take a long, long time, but that's why we should start now. And finally, we will need new technologies, but only for a few sectors, really, and improvements along the way in the others. But we really need new solutions that we don't yet have commercially viable solutions to, things like alternative cement, alternative refrigerants we could probably do soon, but we need to, new ways of making steel and so on that are carbon negative or at least carbon neutral. So we have to develop some targeted technologies, but mostly we need to deploy the technologies we have already. I began this talk by saying what an incredible challenge this all was, but also I see it as an incredible opportunity because we get to reimagine the world. We get to reimagine our energy systems, our transportation systems, our agriculture, our buildings, our cities, everything. And we can maybe build it better than it is today. Sustainability shouldn't be a sacrifice. It should be a better way of doing things in the world, hopefully making a world we can be proud to leave to our descendants. And finally, we need, I believe, more bold vision and leadership. In my country, anyway, in the United States, we now have leadership that is not really about painting a better picture of the future, but really kind of painting the nightmare of the present. And instead of a leadership that inspires, it's really a kind of leadership that blames others for our problems. That's not really the kind of leadership I believe we need. And again, in my country, decades ago, we had a leader, Martin Luther King, who asked us to join him in believing in a dream, not a nightmare, but a dream of equality, a dream of a better world where people judged on the character of their hearts, not of the color of their skin. And he died for that dream, and we're not done fulfilling that dream, but it's a dream that is building a better world. It's taking a long time, but it ultimately is pointing to the right place. And I think this is the same kind of leadership we need in climate change that points us to saying this isn't a bad world we're building to address climate change, it's a better world. And let's invite all of us to join in creatively building a better world for all of us. And that's the kind of leadership I believe we need, but is kind of sorely lacking right now. But in the end here, this is what I would ask of you all, asking you to think about maybe, is it's always important for all of us to continue to learn and share ideas about climate change and climate solutions. I hope our little organization can be helpful to you. Go to drawdown.org or follow us on social media if you like. We just published a new book called The Drawdown Review just about 2 months ago, which is actually free and downloadable on drawdown.org as a readable PDF. You can put it on your iPad or whatever. And share it with anybody you like for free. So I hope you take a look at that. It's very, very useful. But also to remember, most importantly perhaps, that the future isn't written yet and that we can still shape it. And I love this quote that asks us to take the risk and accept the responsibility of consciously creating the future that we want. So with that, I'll stop here and switch it back over and see if we can have some time for questions and conversation, which I'm really looking forward to. So with that, I'll turn it back over to Matthew, and maybe you want to moderate a little discussion here today.
That's wonderful. I really appreciate what a fantastic talk you provided, and I think it was exactly the right aim for the wide variety of students and postdocs and researchers and faculty that we have here. But it is, as you mentioned, a very important topic that cross-cuts all of those areas. So I'm sure there's going to be plenty of questions, and I'll ask the viewers to put their hands up. I can already see some questions in the comments now, so I'll review those. But before I review them, I will ask my own first question as moderator, because it relates back to one of the last slides, which I really enjoyed the path forward for us, what we need to do, what we can do now. I thought that was a great message that you reiterated throughout. But the scenario 1 and scenario 2, I was actually very surprised that we can maintain those 1.5 or 2 degree changes into the future by just implementing some of these very important drawdown processes. But scenario 2, you said, was politically and socially challenging. And I'm curious to see or to hear from you your thoughts on that idea of political and social challenge in light of the present circumstances that we're finding ourselves, where our entire political and social and economic systems have been disrupted. How do you foresee broadly our perspective coming out of this, and how we can harness these changes that we've experienced on a very personal level positively to address the very personal issue of climate?
Yeah, well, again, this is an area where I'm certainly not an expert. Probably no one is. So this is just more of an observation for what it's worth. Well, 2 things. One is that, everything I grew up being told was impossible turned out to not only be possible, they were inevitable. If you told a young American in the 1970s that the Cold War would end and the Soviet Union would be no longer, he wouldn't believe you. Or that apartheid in South Africa could end peacefully and have a coalition government afterward, no one would believe you. Or that this country could elect an African-American president or have legal gay marriage or anything like that. They would have been laughing you out of the room. But those things not only were possible, they were inevitable, and they happened. So when people say, well, climate change is impossible, I say, well, really, that's funny. That sounds like a long list of things I was told were impossible before, but turned out not to be. And none of which were predicted in advance. They all just happened. So the ability to change in this society is probably much greater than we anticipate. So I think that's something, a little bit of moment of reflection and humility, that we often extrapolating the past is never a good predictor of the future. So we have to be careful about that and just be mindful of that point. In terms of the present circumstances, no one really knows what's going to happen. This is totally unprecedented, though not unpredicted, that a giant, kind of pandemic could sweep the world. This was also inevitable. Scientists have been warning us about climate change for 40, 50 years and about emerging infectious diseases and pandemics for the same period of time. And the world's political and business class largely ignored it because it wasn't convenient to talk about. So here we are, though. We have a climate crisis, and now we have a global pandemic, and just the first of many, perhaps. So we need to change our ways. In the pandemic side, we know that these emerging infectious diseases often, though not always, come from the kind of breakdown of ecological systems, whether it's tearing down rainforests that unleash things like Ebola and maybe HIV into the world, the kind of animal trade in wet markets and traditional medicine markets of the world, also responsible for some of this stuff. But also kind of breakdowns in kind of livestock agriculture, the huge operations of confined animals too close together, often pumped with antibiotics every day just to promote a little additional growth right next door to millions and millions of people in some countries. That's a recipe for disaster as well. So kind of like climate change, ecological change is also causing these ripple effects like new storms that are unprecedented and new pandemics. So I think we have to learn that lesson, that breaking down the physics of our planet causes climate change and its associated disruptions. Breaking down ecosystems is also important. We have to learn that lesson. We can't wait any longer to be so ignorant for so long. We just cannot afford that anymore. Science has known that these are problems for decades. What will it take for the world's leadership to believe science finally? I hope this might be a wake-up call to our political leadership and business leadership that science is often right, or at least can provide guidance. And science is also good at telling you when it's wrong. unlike the politicians and the lawyers and the business leaders, at least the ones in this country. So I think we need to be a little more humble. I think we need to respect science more. The other opportunity, as sad as it is incredibly devastating, says we probably are entering a global depression now, first time since the 1930s. Well, who knows? I'm not an economist, but it's looking pretty bad. But what economy will be rebuilt out of that, the ashes of this one? I don't know. Hopefully a better one. Even the Great Recession, which is small by comparison to this, we saw a very big change after that in a lot of economies. The United States, for example, we hit our peak emissions of greenhouse gases back in 2007, and they've been going down ever since, mostly because of phasing out coal, but also that industries got more efficient. Households got more efficient during that time. And so we've seen about a 15% reduction in greenhouse gases. The UK has seen about 45% reduction since their peak of greenhouse gases. And there are now 50 countries in the world that have hit peak emissions and are heading down. China was about to be one already, certainly will be this year. So that's interesting. Which path will we choose? Will we choose a more efficient and renewable powered path mostly? Will we fix our agricultural systems? Can we really wean ourselves off of petroleum quickly? These are big questions, but I think every time you shake up the world, it can settle in new ways. And perhaps a world's leadership can be wiser, a little bit more humility, more respect for science and data would be very helpful. And being, kind of shaking up the system, saying, wow, this current economy, the way we're doing things right now is actually very dangerous. If we keep on the current path, we need to change it a little bit. We don't have to throw everything out. I'm not suggesting that, but we do need to at least modify the path we've been on, if not fundamentally change it. But nobody knows.
Yeah, well, I really like the point. I think even with this current experiment, we see that science can make decisions and lead policy even in the face of uncertainty. I think that's a real analog for the climate debate going forward. I have a page of questions, but I'm going to open up to others. There's one from Manny, and Manny's a professor in our Clean Combustion Research Centre. Manny asks, when looking at various power generation options, can you comment on the feasibility of fossil fuel-based systems with carbon capture and storage?
Well, I suspect, based on his background, he knows more about this than I do. So it'd be bringing coals to Newcastle, if you will, to for me to comment on that. But for others in the audience, the idea that we could burn fossil fuels more safely and capture their CO2 effluent is certainly an attractive idea to preserve the incredible promise that fossil fuels are kind of amazing. I mean, they have the energy density unlike anything else. They are fairly abundant, and they're very, very useful for certain situations. But to my personal belief of looking at the data, that just the economics of those kinds of facilities have just not proven to be very powerful yet. We've been talking about them in the United States, for example, and other countries for 3 to 4 decades. They've received billions and billions of dollars of government subsidies, and we've yet to build one of them at any meaningful scale in the US, for example, or anywhere else that I'm aware of. So I guess color me skeptical. It sounds great, but solar panels and wind and other things are here now and are cheaper to operate already. And that's the price comparison was based on coal and gas operations that don't even have carbon capture, which undoubtedly would increase the price. So to me, it'd be like, why bother? We have a cheaper, better way to do things now, and energy storage is falling in price so much faster than anything else. I think the days of coal and gas being used for making electricity are now over. It's just a question of time before they're replaced. The economics have already won. Solar, wind, and batteries are falling in price faster than anything fossil fuels could keep up with. And they're 21st century technologies. Why should we be burning fossil fuels to make electrons move? Right. It's such a primitive technology. Now, the place where fossil fuels, I think, can still be very viable is in long-range transportation fuels. I don't know how you can fly a jet plane without some kind of liquid fuel. That's going to be very, very important. Maybe we can make synthetic fuels out of the air, out of biodiesels, or some kind of biokerosene, something like that. But yeah, I don't know. I'm not very very bullish on the carbon capture game. I think it's already lost from an economic point of view.
Good
but I
point.
could be wrong. I'd love to see somebody prove that wrong. That'd be great. Very open to that, but it has to be proven and demonstrated now. So we need to see the data.
Okay, there's two questions here from Dario and Mustaqim, two students in the program. They're similar, so I'm going to try and join them.
Mm-hmm.
So you mentioned that drawdowns, there's a huge cost associated with it, and of course, developing nations are going to have to bear this cost as well. So I guess in the current economic system, and you maybe touched on this a little bit in the outcome of all of this process, maybe we're going to be looking at a new economic system. But how do we achieve these? How do we pay for the real cost where there's not shown to be great incentive, or at least the governments don't seem to be great advocates of investing in these easy approaches, I suppose. How do you see that moving forward, especially for developing nations?
Well, again, the costs are actually negative for most things. If you actually look at the lifetime cost, there's some upfront capital cost of doing anything new, of course. And the numbers we looked at were comparing the current world, where we're powered mainly by fossil fuels and industrial agriculture, to a new world where we have to kind of shift a little bit. And in that first year, yeah, you'd have to spend a little bit of money, but not much compared to other, to subsidies we put into the current system, the size of, let's say, global military budgets. It's actually a trivial amount of money. $25 trillion spread over 30 years across all the economies of the world isn't all that much, really. And it will feed back at least a net savings between 90 and $140 trillion. So we can't afford not to, is the answer. Basically, if we don't do that, the way I should have framed this is if we don't begin to address climate change, we're wasting between 60 to 120 trillion dollars we're throwing away and causing devastation to the planet. So I don't buy the thesis. It doesn't cost more, it costs less. Mm-hmm. If you include the operational cost and the new revenues that we can be looking at. So actually, I don't agree with the thesis. Maybe I should have presented it more clearly. It's cheaper to build a renewable powered world than a fossil fuel world, for example, by far. It's just a different world. The real question is it's not about the global economy. There is no such thing. There's lots of winners and losers, and there will be some places that will begin to lose economic power over this, certainly. And you guys are in Saudi Arabia, obviously there's one interest there. Also in Russia, the United States, other places. There'll be some people who will be very upset about this. And most of the world, though, will benefit from this. So it's more about the political economy than the global economy. It's like, who are the winners and losers? Who has more power at the moment to make decisions and to slow things down? That's really what's going on. It's very hard to separate politics from economics when you look at power dynamics here. And we just have to acknowledge that and realize that it's real, and that will be a tension, as any global changes in our economic systems will create. Whether it's globalization and shifting manufacturing to other countries, whether it's new technology or automation or AI, these are disruptive forces that change who gets to do what. But they'll happen anyway. So I think the smart money is on being ahead of those changes, realizing they're inevitable. And I would bet on those if I were an investor today than on coal and oil and gas, because those are inherently going to lose. It's just a question of when. And if we look at the global oil markets today, I think we're seeing part of that play out now. So it's a very interesting time, obviously very challenging time to make this transition, but I think it's inevitable. And it's not only possible, if you're a capitalist, you would say by far the best thing we could do is address climate change. We'll make more money doing so. No question. And avoid catastrophic damage. So if people say they believe in capitalism, they have to be a believer in stopping climate change. Otherwise, they're just a liar to themselves. They're not looking at the numbers. So it's a better technology. It's a better system for most things. Not everything. I believe there still will always be some future for fossil fuels, but more as a niche technology for very important things. Perhaps in polymers and petrochemicals, maybe aviation fuel, things like this, but much, much smaller. The idea of using it to make electricity and moving cars around, why? We don't need to anymore. Those days are numbered, and they have been for a long time.
So another question from Ananya Ashok. She's a student in our Red Sea Research Center. Mm-hmm. And this actually, I'm going to put a little twist on it as well, because there's a present comment that we can draw from it. So she asks, how is the considerable or comparable impact of urban density population cities versus rural areas? You mentioned, we've shifted in recent years to urban cities away from rural areas. What is that relative contribution in terms of emissions? And how can already complex old cities be made more climate friendly? And I would add to that, perhaps do you think we're going to see a change in the way that we are living? Certainly, we're expecting. We're seeing increased efforts and emphasis on locally produced products and sustainability in response to the present challenge that we're facing now. We're looking at more security of food support sources from local supplies. I guess they're all interrelated. So, can you comment on that?
Yeah, that's a more complex problem than just climate change. But right now, the trajectory, which could change, but is for more and more urbanization. More people tend to are moving to cities for economic opportunity, for social opportunity, especially younger generations. If you look at the demographics of this, younger people are even more urban than the population as a whole. Which is quite interesting. So I think you're going to see more movement to cities for quite a long time. Almost all the demographers show that kind of trend, but it could change. That's a very interesting question. Local production isn't necessarily more sustainable. It might build in more resilience. For example, local food is not more climate friendly than distant food. It's much more important to know how your food was grown than where it was grown. The transportation of food around the world is actually quite inexpensive from a carbon point of view. In fact, most of the emissions of greenhouse gases in food transport happen in what's called the last mile, or the last kilometer, I guess we should say. And it's mostly the consumers bringing food home from the store is where most of those transportation emissions occur. If you look at very large food commodity traders, they're incredibly efficient at packing food into giant containers and putting them on ships. Ships are actually an incredibly efficient way of moving large volumes of material around the world per barrel of oil burned, for example. So it's really, I don't worry about that. But local food is very good to kind of have a backup supply that you control and you're not dependent on international markets for. That makes a lot of sense. And also, puts money in the hands of local farmers and local communities, which is great too. So I think it's more of a social thing than an environmental one. And sometimes we can make big mistakes with local food. Over irrigating places near, in Saudi Arabia has experimented with this. I live in California. We've totally overdone this. Overtaxing water supplies that are inherently limited to try to grow more food locally isn't very sustainable either. So I think we need to look at the kind of the wisest path for food is not always near us, but the best farmers, not necessarily the closest. Probably what we have to think about. But the other thing is more about redundancy. Economists love efficiency and reducing duplication in markets. Like, let's put all of the, for example, a number of years ago, I was working with a company to analyze why the prices of oats were fluctuating more and more and more in the last 2 decades. This is a company that buys more oats than anybody in the world. And they were wondering, does climate change causing this, or just seeing wild price spikes and availability spikes of oats, just one of the grains we eat in the world? And they thought, well, maybe this is an early sign of climate change or something like that. Is it severe weather? What's going on? No, it wasn't that. What it was very simple. Is back in the 1950s and 60s, there were about 20 places in the world that grew oats. Today, it's only 2. It's like Saskatchewan and the Ukraine. And if one of them is having bad weather, that's like half the world's oat supply. Mm-hmm. So in the name of kind of market efficiency, we kind of consolidated too much of our food production in too few places, with only 2 handfuls of companies being responsible for the lion's share of that. And those systems can break down, as we're seeing today. Supply chains that are too brittle, that don't have, from a business point of view, efficiency means you don't keep stockpiles of anything. Everything's just-in-time delivery from China to your doorstep for a new iPhone or whatever it is, or from that market to your kitchen. There's no redundancy, no delay, no storage. That's beautiful if everything's working well. But in fact, inefficiency is actually your friend during a pandemic or during a disruption, because inefficiency means there's a little bit of a give in the system that you can exploit during a bad time. So I think we have to relearn economics and incorporate the idea of resilience into the system, not just efficiency. It's odd that we love efficiency in many ways, but sometimes it's actually not the best idea. So that's a complicated question, but yeah, I think localization is good for resilience. Not always better for the environment, but it can be depending on the situation. But in a water-stressed area, for example, not really, not in the long run, or you have to be very careful about it. But also begin to think about resilience in the key supply chains that our economy and civilization depends on. We need probably more duplication, more safeguards, more kind of a shock absorbers in the systems that allow us to have a bit more resilience, just in case. That's hopefully another lesson we might learn from this experience of this last year or so.
Yeah, I totally agree. I think resilience is going to be the word of the year.
Yeah, it could be.
I've just got two more questions. There's one here. Given the obvious multiple benefits and social, political, and economic advantages of reducing CO2 emissions, or maybe not political, why do you think these measures are taking so long to be implemented?
Well, to be blunt, corruption. We have a handful of very, very powerful interests who have stopped this from happening. I'll just speak to the United States because that's where I live, but I think you'll see other examples that you can think of in your situations and others around the world. But we have, basically entire industries who've bought the U.S. political establishment. I don't live in a democracy anymore. It's for sale for the highest bidder. Vladimir Putin runs the American White House now. Clearly, oil companies have bought more than half of Congress. Even during the Obama administration, it was impossible to pass a carbon cap and trade bill, even though Democrats controlled with huge majorities our two major chambers of our legislature and a very popular newly elected president. Even then, we couldn't still get things passed. So it's really the corruption of democracy with money and power that has stopped this. The science has been clear for 3 decades. So I don't think the scientists have made the best case of this very well. I think we've communicated it very poorly. We've communicated only the negative side of it, not the opportunity side of it. We've talked more about the problem than we have solutions. So I think we've lost some time not being effective communicators, but mostly we're fighting an incredibly corrupt system where scientists are being threatened with their lives in the US and elsewhere around the world for even talking about this. I have a lot of friends who get death threats every day for just speaking truth and talking about temperature records. Who would have thought thermometers would be so controversial, but they are. It's really greed and corruption of a few that's changing the political landscape for the rest of us. I think if we actually had 1 vote per citizen of this planet and everyone was provided with good scientific information to make better decisions, it would overwhelmingly be, we'd have already, tackled this problem a long time ago. Again, that's my personal opinion, not a scientific one, so I can't, not an expert on that. Probably no one is, but it's an observation of, the last 30 years in one country that, has done a spectacularly bad job of addressing this. And it has nothing to do with the science or the economics. It has to do with corruption and power. And then we have countries in the world who obviously have a lot of stake in this as well. And also in different industries, different individuals. But we have to remember it's a very small percent of the world's economy that's really powering fossil fuels and only a few actors. And that we have to make a graceful transition, to a different world. And that's just the way it is. So yeah, I think it's we might as well be honest and say what it is.
Great answer. Jonathan, one final question. I often think about this myself. If I had my time over, what would I study? We've got a room full of environmental science students and others. What would be your advice? If you had your time over, what would you study, or what would you recommend the students of today focus on?
Well, I guess I started out wanting to be an astronomer, so I was an undergraduate in physics. I would probably do that again because it's very useful training for almost anything that I'd like to do. But I liked math and I liked doing physics. So I think Then my PhD is in atmospheric science and oceanography, which I barely use any of that stuff anymore. I'm doing other things now. But I think whatever I'd recommend is there's no one profession that's going to fix the world by itself. So I would study whatever you love, what makes you happy, what are you good at, and be the best one of those you can be. But the important thing is to link to other professionals in very different disciplines and very different career paths than yourself. And that's how we solve problems. So if you are an engineer or you're a scientist, great, be a good one, but make sure you learn how to talk to policymakers, to lawyers, to business leaders, to journalists, to writers, to artists, to activists, many of whom you may violently disagree with. That's okay, we're supposed to. But to learn how to have those conversations and those collaborations. So just get outside of your circle of what you think. Make sure you're, my two rules are, if you think you're the smartest person in the room, you're in the wrong room. Get out of that room and find a room with smarter people than you so you can learn more. But also make sure you're not in a room of people who are just like you, either by profession or by, gender, skin color, or whatever. The diversity is how nature works. And so diversity of ideas and professions and people are really, really powerful. So we need an ecosystem of professions, not a zoo where we're all locked in individual cages, not interacting. We really need us to interact. So many of my students have asked me that over the years too. I think there's a little bit of a thinking that, oh, those people over there must be more effective at making the world better than I am. You know what? They're thinking the same thing looking at you. The grass always looks a bit greener on the other side of the fence, but it's not really true sometimes. I would say, do what you're good at. We'll need you there. Do what you love, so you find the energy and sustaining yourself over time that you can keep happy and productive and fulfilled doing it. But for God's sake, get out of your bubble of just the few people you talk to. Get out of the academic world as much as you can. Get out into the real world of either industry, business, politics, but also just everyday people who never, the lives you can't imagine today. Yourself, we're all so limited in our experience. I think that's really the key to better problem solving is more collaboration, more humility, and always learning and realizing we all know very, very little. And we need to collaborate if we have any chance at all of solving these problems and to truly listen. My mother had a weird expression. She said, we're all born with two ears and one mouth. Try to use them in that ratio. And, so maybe those are some parting thoughts for advice for students today.
Oh, yeah, it's fantastic. John, thanks so much, one, for getting up early, and then two, spending the time to impart some great wisdom to the audience. I'm sure you're going to get a lot more views onto the Project Drawdown website. There'll be a lot of interest in there. I've got, as I said, I had a page of questions here. There's really going to be plenty others. We'll have to have another conversation in the future. It's
okay. Well, thank you very much for the opportunity to be with you today, and good afternoon where you are. And yeah, if you could take a look at our website, drawdown.org, that'd be great. And maybe share it with some of your friends. That'd be very welcome. We'd love to make sure that there's we've made a whole new book and all of our resources available and free to the world on purpose. And we don't have a large footprint in Saudi Arabia yet, but maybe you can help us get a little foot in the door there. That'd be wonderful. So thank you so much for your time today. I really appreciate it.
All right, John.
Thank you. Cheers.
Bye-bye. Thanks, everyone. The video will be recorded. We'll pass it on when that's finalised, and feel free to distribute to others who may not have been able to make the talk. Thank you all.